Okay, we had determined in our last video that it was about 1 in 5 chance that Mr. Owen would roll 3 of a kind or 4 of a kind or 5 of a kind, 3 or more of a kind. So I got a bit lucky. There's only a 1 in 5 chance that I would get something like those 3 2s showing up. But there's also the probability of getting a full house. All right, so what we'll explore in this video is the odds that I would get 3 of a kind and 2 of another kind. All right, the odds of that should be lower to achieve that in a single roll. And by the way, this was not rigged; it did happen by pure chance. So the odds of getting 3 2s and 2 6s is probably lower than just getting 3 2s and anything else. So there's a little bit more order here than just getting 3 2s and anything else. So the odds are lower that would happen. So anyhow, let's explore the probability of getting a full house on one roll. Okay, so first of all, let me define what a full house is. Some of you, hopefully not too many of you, do a lot of gambling. So a full house is when you have, usually it's with cards, you have 3 of one kind and 2 of another kind. Okay, so it wouldn't be 5 of the same card. That would actually be, well, in cards you would never get 5 of a kind. But in Yahtzee, you can get 5 of one kind, but that's a Yahtzee, not a full house. So it's a triple and a pair. So we want to figure out the probability of that. So what we'll do is we'll start with the specific example we had and then build up to all of the possible ways to rearrange that. Okay, so what did we do? We're just going to shorten this, the probability of rolling 2 6s, because we have 2 6s. Then, okay, so we're going to start with where the order matters. Then 3 2s. Okay, so the order will matter. All right, so what is the probability of that happening? Okay, so the probability of, I'll write 2 6s, then 3 2s. These are all independent events, so we can multiply probabilities. And so to get 2 6s, it would be 1 in 6 times 1 in 6. And then if we specifically needed 3 2s, so those are the probabilities of getting the 2 6s, and then specifically getting the 3 2s, there's a 1 in 6 chance of succeeding each time. If I need to get 6 6 2 2 2, I have a 1 in 6 chance each time, so that's 1 in the total 7,776 again. All right. Now, how can we order those? All right, so we need to figure out the number of ways next that we could get. So we'll look at the probability of 2 6s and 3 2s in any order. Okay, so we have to look at the way that we could organize 2 6s and 3 2s. Okay, so once again, there are 5 things. So the ways to organize that would be 5 things. There are 2 6s, so we would divide by 2 factorial. There are 3 2s, so we would divide by 3 factorial because we don't reversing the order of the 6s or switching up the orders of the 2s will make it look like it's the same outcome. So this is the same as C5 2 or C5 3, doesn't matter. Those will be the same answer. But if we look at that, 5 times 4 times 3, I'll call that factorial, over 2 times 3 factorial, and we again get 10. Okay, so there are 10 ways that we could get 2 6s, then 3 2s. So the probability of 2 6s, I'll just say 3 2s, is equal to 10 out of 7,776, because there are 10 ways that we could order that. Okay, so there we are at that point. Now let's take this just a step further. Okay, so now what we want to do, let me hide my keyboard there. We want the probability of getting a pair and a triple. We could do a triple, then a pair, it doesn't matter. The answer would be the same. So we want to get, two of a kind and three of a kind, so pair and a triple, I'll call that. So how does that change the previous answer? All right, well, it's the counting principle all over again. How many ways could we have? Let's assume that the pair comes first. All right, so if the pair came first, there would be 6 ways to get a pair. All right, it could be 2 1s, 2 2s, and so on up to 2 6s. Now with the triple, because it can't be the same as the pair, there are 5 ways left to get the triple once you've established what the pair is, right? So what we need to do is take 6 times 5 times the previous answer, all right? So we had a specific answer here where we were specifically getting a pair of 6s and then a triple of 2s, but it could have been a pair of anything. And then instead, once we established what the pair was, it could have been, there were 5 other triples left. So the answer is 6 times 5 times the probability that we previously had. All right, so we have 30 times 10. So that looks like it's 300 out of 7,776. All right, so it's not very likely, but it's not impossible that that would happen. In fact, you just saw it happen. So what are the odds? Let me compute that as a percentage. 7,776. All right, it looks like we had as a decimal 0.0386 when I round it. So we'll call that 38.6. I'm sorry, that is not 38.6%. That is 3.86%. So not very likely. In fact, it's much less likely than the probability of having rolled just a 3 of a kind. And we saw that was about 1 in 5 or 20%. So to get 3 of a kind and a pair in addition to that is a much lower probability. So that's what the chances are of rolling a full house on one roll are. Now, in the game of Yahtzee, remember, you get to take the dice and re-roll the ones that weren't favorable. You get 2 more chances to re-roll. So the odds of getting a full house are actually pretty high over 3 rolls. It's not very high over an individual roll. And the reason why it's pretty high in 3 rolls is, let's say that I did get my triple. So I had the 3 2s. And then let's say I had a 5 and a 4. All right. If I were to re-roll the 5 and the 4, the chances of those being a different pair are reasonably, aren't so vanishingly small. Or if you think about it, if I just rolled the 4 twice, it's likely to end up being a 5 over 2 rolls. It's a reasonable chance. Also, it's likely that it would also come up as a 2, which would end up giving me a 4 of a kind. So because of re-rolls, probabilities of things become much greater.